Welcome back, everyone. This is video 69. Today we're going to be taking a look at ovulation and the menstrual cycle. Both of these are very hormone driven, so we're going to see a lot of hormones that we maybe haven't mentioned before. So make sure you're able to keep all of them straight as we work through these two processes. So the process of ovulation is all about the release of a mature follicle. And so follicles are going to progress through certain stages from primordial, primary, secondary, and then tertiary stages before ovulation takes place. And those progressions are going to take place over about 2 months, though an oocyte is going to be released every 28 days. So you basically have 2 cycles going as these follicles are progressing at once. Primordial follicles are going to be present in newborn females. They're going to have a single layer of supporting cells around the oocyte to help protect them. After puberty, some of those primordial cells are going to grow into primary follicles. And then secondary follicles are going to have the supporting cells increasing in size and layers. Those cells are also going to be producing estrogens, which are going to be important. And then some of them are going to develop into tertiary follicles, only one of which, however, is going to develop until the oocyte is actually ovulated. So you may remember from a previous video where we were talking about the meiosis that's taking place in oogenesis and with spermatogenesis. Most of that cytoplasm is being donated to the one that is actually going to be ovulated. And then follicles that are going to stop at any point in the process, they're going to become known as polar bodies and eventually undergo atresia, which is where they eventually die and are resorbed by that ovary. So here you can see an image of each stage of these follicles, starting from that primordial, then moving to a primary, and then developing into secondary follicles, and eventually into a mature follicle here. These are the supporting cells that they will have around them. Eventually, that oocyte is going to be ovulated. It's going to be released. So here we have the ruptured follicle with the release of that ovum. And then we'll take a look at the path of that ovum once it is ovulated, but the supporting cells are still going to be around. They're going to start to become what's known as a corpus luteum. Eventually, though, that corpus luteum at the end of its life stage will begin to degrade and will be known as a corpus albicans before it is fully resorbed. So the hormones that are involved in ovulation, you're going to start with those involved in the follicular phase. And so at this point, the hypothalamus is going to be producing gonadotropin releasing hormone, or GnRH, which is signaling the anterior pituitary gland very close to that hypothalamus to produce FSH, follicle stimulating hormone, as well as luteinizing hormone, LH. So FSH and LH are going to be the ones that travel to the ovaries. FSH is going to stimulate the growth of follicles, which is why it's called follicle stimulating hormone. LH is going to stimulate the follicles to produce estradiol, which is a type of estrogen. The more developed a follicle is, so the further along in its progression from primary to secondary to a mature follicle, the more estrogen that's going to be released. And so when you get higher levels of estrogen, that's actually going to negatively be negative feedback and inhibit gonadotropin releasing hormone, luteinizing hormone, and follicle stimulating hormone in that hypothalamus and anterior pituitary gland. And so this reduction is why only one follicle survives. Basically, you aren't getting the development of multiple follicles being told, or basically you aren't getting more FSH and LH causing more follicles to continue to grow and develop, because they're being negatively inhibited by the one follicle that is reaching that end of stage, that more mature stage. After the follicular phase, you reach the ovulation phase. So when there's only one follicle left, it's going to secrete more estrogen than all previous follicles had before. Basically, you have a very, very high amount of estrogen. You get an estrogen spike, essentially. At a certain point, there becomes so much estrogen that the negative feedback loop no longer starts taking effect, and actually it will trigger the opposite. It will trigger the anterior pituitary gland to secrete lots and lots of LH and FSH, and actually a positive feedback loop. So it no longer is a negative feedback loop. There's so much that it switches to a positive feedback loop. And so the surge of luteinizing hormone especially is going to lead to ovulation of that oocyte and the luteinization of that collapsed follicle into that corpus luteum that we saw in that previous slide. We do abbreviate the corpus luteum, the CL. And then after ovulation, you get the luteal phase. So the CL is going to be producing progesterone. I think of progesterone as being pro-pregnancy because it's going to help establish and maintain a pregnancy by telling GnRH, LH, and FH secretions to basically stop, because those are the hormones responsible for the growth and development of a new follicle. And if you're hoping for a pregnancy, you're hoping that the follicle that was just released is fertilized and implanted, and you don't have to worry about releasing any more oocytes for the near future. If no pregnancy occurs within 10 to 12 days after ovulation, the CL is going to degrade. Again, we saw that as it degrades, and as it degrades, that progesterone is going to be secreted in decreasing amounts to the point where GnRH, LH, and FSH are able to start taking back over. They're being inhibited less, and you get the next stage for that ovarian cycle. So here you can see the positive and negative feedback loops that we have for the follicular phase, the ovulation phase, as well as the luteal phase, which we just mentioned on the previous couple of slides. Okay, so as it relates to the menstrual cycle has an immense regularity, at least for most people it does, and you really hope that it has this regularity because you're counting on these hormones to have this pattern as they go through each of those three phases. Typical menstrual cycles are going to last 28 days, although it's going to be different for different people. There's been cycles that are short. 21 days to 3 months can actually fall within kind of a range of normal menstrual cycles. Some, in extreme cases, you'll see some that are very, very short and some that are very, very long, however. But the three phases of the menstrual cycle we're going to see, it's going to start with menses, then we'll move to the proliferative phase, and then to the secretory phase. So menses is going to be about 4 to 5 days of menstrual bleeding. That's going to be where patches of the endometrium are going to be sloughed off. As they are coming off, those patches of dead cells are leaving torn blood vessels behind that were previously feeding them and causing them to grow and proliferate. And so you lose these blood vessels, or you lose these cells, they leave torn blood vessels, and that's where you get this menstrual bleeding. Typically, menses is going to begin due to low progesterone, low LH, low FSH of the follicular phase. Again, you were unsuccessful in having a pregnancy, and so those progesterone levels drop, and so you end up with needing to get rid of the endometrium and all those thickened lining of the uterus to prepare for the next cycle. During the proliferative phase, it's going to last until ovulation, so about days 6 to 13. So the menses is days 1 to 5, proliferative phase is days 6 to 13. That's going to be where follicles are maturing, the uterine lining is thickening. Basically, as those cells are increasing in number, that's called proliferate, and so that's why we call this the proliferative phase. At this point, estrogen is going to be at its highest level. Remember, we're going to see that spike in estrogen as well as LH and FSH right before we get to ovulation. Here you can see the different hormones. So we haven't talked about, or we have talked about these. So you have FSH levels leading up to ovulation here on day 14. You have luteinizing hormones spiking at day 14. That's going to cause ovulation, as well as the spike in estrogen just before ovulation. And then after ovulation takes place, progesterone is going to increase in hopes to be able to hold on to a pregnancy. Down here you can see what the ovary will look like from the oocyte to the ovulation to the CL on the inside. And then here, this is what the lining of the endometrium, that inner lining of the uterus, would look like as it thickens thanks to progesterone in hopes of maintaining a pregnancy. Ovulation, when the ovum is going to be released from the ovary, we typically are going to call that to be on day 14. And then it's going to be followed by the secretory phase, which is going to last from days 15 to day 28, which after that day 28, then you would be the next menses, and that would be the next cycle. So during the secretory phase, you have the highest levels of progesterone. Again, it's trying to hold on to as much of that uterine lining as possible in hopes for a successful pregnancy. By about day 26, however, if no implantation has taken place, that corpus luteum is starting to degrade and it is going to stop secreting progesterone. The cycle will then repeat. You'll start back over with menses. You're going to shed that built up endometrium, and that cycle is going to repeat over and over until menopause, typically around the age of 50 in women. So here's another image, very similar to the one we just saw a couple slides ago on what the ovary looks like as that follicle matures, that is released, and the remaining supporting cells become a corpus luteum. Here you see your FSH and your LH levels, your estrogen and progesterone levels, as well as the thickness of the uterus over the course of a single menstrual cycle. One other thing I wanted to add here, because I didn't really know exactly where to put it with the rest of these videos, is to talk about hormonal birth control from the female perspective. So birth control pills for females take advantage of that negative feedback system between ovaries and the menstrual cycle. Basically, they're going to be providing constant levels of estrogen and progesterone, while also inhibiting the release of FSH and LH from the hypothalamus and the anterior pituitary gland. So without FSH and LH, because they're being inhibited, those follicles are not going to mature. Ovulation is not going to occur. And so if you don't have ovulation, you don't have an oocyte that is available for fertilization. You do get some endometrial wall thickening during this time, or hormonal birth control. Typically, though, it's very, very light. And so even if a fertilization, or even if ovulation did occur for some reason, and fertilization did occur for some reason, implantation would be unlikely because there's not a good base of endometrium in that uterus to properly house the fertilized zygote. Some hormonal birth controls do contain a week of placebos. I should say some. I shouldn't say some. Most actually contain a week of placebos to allow menses to take place, because women like the confirmation that menses shows that they are not pregnant. Though it is possible to get hormonal birth controls that do not have those week of placebos, and thus you don't have menses at all. So it kind of depends on if you want the confirmation that you are not pregnant or not, based on whether or not you have placebos and thus have menses. So that is a look at ovulation and the menstrual cycle. Very, very hormonal driven. Very, very interesting to take a look at how the body is able to use negative feedback as well as positive feedback as it looks to carry out this cycle in hopes for a successful pregnancy.